All right, hello, welcome back. So I just want to go over adding polynomials. So our zero pairs, we'll start off with algebra tiles, zero pairs. When we have a negative and a positive that are like terms, they eliminate, they create a zero pair, they make a zero, they cancel out. You might have heard it referred to like that. Positive and a negative right here. Oh, let me move me out of the way. All right. So a positive and a negative here, again, they eliminate their like terms. They're the same shape. They create a zero pair. So let's come down here, adding polynomials. So 5x. So I'm going to draw out 5x. So that's going to be the long ones. 1, 2, 3, 4, 5. And then I have 3x squared. So that's going to be 3 large squares. 1, 2, 3. And then I have 3x here. So I'm going to add 3 more x's here. 1, 2, 3. So when my camera focuses, we are going to count up my like terms. There we go. All right, and move myself up a little bit. Now I'm not blocking anything. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8 x's. And 1, 2, 3x squared plus 3x squared. Now typically we write in standard form. Standard form would be highest exponent to lowest exponent. So my final answer in standard form would be 3x squared plus 8x. I cannot combine these anymore because they're different shapes, and we saw that from the algebra tiles before. I do want to go over another example. Without the algebra tiles, I'll show you a different way to solve. So if we have negative x squared plus 4x minus 7 plus x squared minus 5x plus 3, I would like to take the like terms and write them underneath each other. So negative x squared and x squared are like terms. I'm going to write that one. Negative 5x and 4x are like terms. I'm going to write that. Positive 3 and negative 7 are like terms. They're both constants. Remember, like terms have the same exponent and same variable. So if I combine those, positive x squared and negative x squared, they're the same term, just opposites. They are going to create a zero pair. So I am going to cross them out. They made a zero pair. Now I have 4x and negative 5x. So let's think about that. If I have 4x, all right, that's 1, 2, 3, 4 x's, and negative 5 x's, I'll make them red. 1, 2, 3, 4, 5. So, using the same idea of zero pairs, a positive x and a negative x would eliminate. Positive x and negative x eliminate. They make a zero pair. A positive x and a negative x, again, they eliminate. Positive x and negative x eliminate. So all I am left with is 1x. If I take a positive 4 and I subtract 5, I am left with a negative 1x, or just a negative x, which is what I have here. Remember, the red tiles are always negative. Now let's take negative 7 and positive 3. I'm going to show you another way, just in case the algebra tiles don't work for you. If we think of a number line, so if I start off at negative 7 on a number line, negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, and this would be negative 8 in this direction. Okay, so if I start off at negative 7, I start off here, and then I'm going to add 3. Started at negative 7, I'm going to add 3. Move 1, 2, 3. I end up at negative 4. So when I combine these two numbers, I get negative 4. This is the same idea as using the algebra tiles, just a different representation. So if you like doing the algebra tiles and finding your 0 pairs, that works. Otherwise, we can use this method where you use your number line. Okay. Again, circle the final answer, and that is adding polynomials.